بسم الله الرحمن الرحيم. بنبدأ مع بعض أسئلة chapter 5. Let's start to answer exam view for chapter 5. We will start with conceptual questions. Number 1. In a collision between a huge sports utility vehicles and a small hybrid car, the sport utility vehicle exerts a larger force on the hybrid than the hybrid exerts on the SUV sport utility vehicle. This information from Newton's third law is wrong, is false. Why? Because for any action there is an equal and opposite reaction. The force exerted by SUV exactly equals the force exerted by the hybrid small car. Let's go to number 2. A box is placed on a table which rests on the floor. So I have the table here and this is the floor. The box pushes on the table. I have a box here, small box here. So the box pushes on the table. The reaction force to the box's push on the table is the table's push on the floor? False. Why? The reaction force is the force exerted by the table on the box, not on the floor. So the answer is false. Number 3. In order to get an object moving, you must push harder on it than it pushes back on you. Imagine that you want to push this box to make it move. He said in order to get the object, the box, to move, you must push harder on it than it pushes back on you. Guys, don't forget Newton's third law. If you push with a specific force F on the box pushes back with equal and opposite force. So this is false. Let's go to number 4. A girl attaches a rock to a string, which she then swings counter-clockwise in a horizontal circle. As you see, the string breaks at a point B. In the figure, which shows a bird's eye view as seen from above, as you are a bird, which path A or B, C, D, E will rock follow? Guys, when the rock moves on a circle, because there is a centripetal force, so when the string cut or she leaves it, there is no force acts on it, so it will move in the direction of B, not A or C or D or E, because there is no force acts on it right now, so the direction will be B. Number 5. If you pound a feather with a hammer, which one feels a greater force? Guys, always remember Newton's third law. You have a hammer and a feather. For any action, there is an equal and opposite reaction. So the force exerted by the hammer on the feather exactly equal the force exerted by the feather on the hammer. So the size of the force is always exactly the same on both of them. The answer is C. Number 6. A satellite is in orbit around the Earth. Which one feels the greater force? There is no one feels the greater force because the forces are equal. Earth and the satellite feel exactly the same force. So the answer is C. Number 7. You pull on a crate with a rope. There's a crate here, and you pull with a rope. If a crate moves, the crate starts to move. The rope's pull on the crate must have been larger than the crate's pull on the rope. But if the crate doesn't move, both of these pulls must have been equal. In both cases, the crate moves or doesn't move. The force that you pull with on the crate exactly equal the force that the crate pulls you. So this is false. Let's go to number 8. As you see, all of the problems up till now deals with Newton's third law. In order to lift a bucket of concrete, you want to lift a bucket of concrete up. You must pull up harder on the bucket than the bucket pulls down on you. This is false. Why? For any action, there is an equal and opposite reaction. Number 9. If the rockets of a spaceship in outer space, far from all gravity, there is no gravity, suddenly lose power and go off, the spaceship will gradually slow to a stop. Why? 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 Is there any force acting on the spaceship? No. So if no force, so the net force equals 0 means it will move with constant velocity related to Newton's first law. So it is false. The spaceship will continue moving with constant velocity because in space there is no net force acting on the spaceship. Let's go to number 10. You are in a train traveling on a horizontal track and notice that a piece of luggage starts to slide directly toward the front. So imagine you are in the train and suddenly this piece of luggage slide directly toward the front. From this observation, you can conclude that this train is. I want you to imagine that you are riding next to your father in the car, and suddenly, if your father slowing down, what will happen for your body? Will move forward. The same, guys, because of inertia. So that means from this observation, you can conclude that the train is slowing down because the luggage wants to keep moving with the same speed as the train was doing before. So the answer is B. Number 11. While flying horizontally in an aeroplane, you notice that a string dangling from the overhead luggage compartment hangs at rest at 15 degrees away from the vertical toward the front of the plane. This is the front of the plane. And this is the luggage, and the line of the string hanging at rest at 15 degrees from the vertical. This angle is 15. Using this observation, you can conclude that the aeroplane is, imagine the string moving toward the front, means the aeroplane starts to slow down. And the string wants to move with the same speed as the aeroplane did before. So, the answer will be D, accelerating backward. Accelerating backward means slowing down. The speed starts to decreases. So the answer is D. Number 12. An elevator suspended by a vertical cable is moving downward. This is the cable, and this is the elevator, and this is the direction of the motion, Fy. But slowing down, so the acceleration is negative. The tension in the cable must be, this is the tension of the cable. Let's solve it like a free body diagram. This is the tension, and this point represents the elevator, and this is the weight, right? And this is the direction of the motion. So Fy equal W minus T. W in the same direction as Fy. Fy means MAY equal W mg minus T. So take T to the other side, equal mg minus MAY. But AY, so mg minus AY. But AY is negative. So T will be mg plus AY. Why AY is negative? Because the elevator is slowing down. Means the acceleration is negative. So as you see, T is larger than the weight. Because T equal mg means the weight plus MAY. So the tension is greater than the weight. So the answer is A, greater than the weight of the elevator. Number 13. A crate is sliding down an inclined ramp. At a constant speed. Hold on. Constant speed in straight line direction means constant velocity means zero acceleration means the summation of force equal zero because acceleration is zero. So here he asks you about the vector sum of all the forces acting on this karat must point that there is no net force. So there is no direction here. for the force, the net force, the sum of the force. So down the ramp wrong, up the ramp wrong, perpendicular wrong, vertically downward wrong. None of the above choice is correct, because the net force equal what? Zero, because zero acceleration, constant velocity, constant speed in straight line. So the answer is E. Number 14. A bucket is being lowered by a very light rope with a constant downward velocity. The tension in the rope must be constant. Velocity means the summation of the force equals zero. Means the weight downward exactly equal the tension. So the tension in the rope must be exactly equal to the weight, equal to the weight of the bucket. So the answer is A, because constant velocity means zero net force, zero acceleration, means the total net force equals zero. So the tension upward exactly equal the weight downward. Number 15. Bill and his daughter Susan are both standing on identical skateboards with really good frictionless ball bearing. There is no friction. Initially at rest. Here is a small boy Bill, or the daughter, the female, the daughter, and here is her father. Bill weighing 3 times as much as Susan. His weight 3 times. His mass is 3 times. Bill pushes horizontally on Susan's back, causing Susan to start moving away from Bill. He pushes it back, so she moves back. Also, he will move back because there is no friction here. Just after Bill stops pushing, directly after pushing, what will happen? You know well that F from the father on the girl exactly equal from the force from the girl on the father, right? His mass 3 times her mass. So her mass, his mass M, her mass M over 3 times acceleration. Here, her mass M over 3, and here his mass M. So, to make this force exactly equal this one, here the acceleration will be 3 times the acceleration of the father, right? So 3 goes with 3. Means here speed will be 3 times the speed of the father. So Susan and Bill, Susan, his daughter, and Bill are moving away from each other, and Susan's speed is 3 times that of Bill, because the acceleration is 3 times. And initially we're at rest. You know that acceleration equal V final minus V initial over T. V initial for both equals 0. And same time. So make it 1 second. So A equal V final. Got it? So the answer is A. Number 16. You push on a box G, U, push on a box G. You push on a box G that is next to box H, causing both boxes to slide along the floor as shown in the figure. The reaction force to your push is you are pushing on G, so G pushing on you. So the push of box G on box H, no. The push of box H on box G, no. The push of box G against you, yes. You push on box G, so the reaction force G is pushing on you. So the answer is C. Number 17. A small car and a large sport utility vehicle are at a stoplight. This is a large SUV car and this is a small car. The car has a mass equal to half that of the SUV. So this is 2M, this is the car M. And the CUV car can produce a maximum accelerating force equal to twice that of the car. So here is 2F and here is F. When the light turns green, both drivers push their accelerators to the floor at the same time. Which vehicle pulls ahead of the other vehicle? Means go faster than the other after a few seconds. Hold on. What is the acceleration here? A equal 2F over 2M equal A. Here F over M equal A. So the same acceleration. So it is a tie. Means a draw. So the answer is C. Because as you see, same acceleration. Number 18. An object is moving with constant non-zero velocity. Constant non-zero velocity means summation of force equals zero. Which of the following statement about it must be true? A constant force, a constant force, a constant force. The net force on the object equals zero. The net force on the object is zero. Constant velocity, guys. So the answer is D. 20-ton truck collide with 1,500 pound different unit. Okay, guys? The ton, 1,000 kilogram. The pound, 445 grams. Which of the following statement must be true? During the collision, the force on the truck greater? No. The forces are equal. During the collision, the force on the truck is equal to the force on the car. This is true. For any action, there is an equal and opposite reaction. Number 20. A truck is using a hook to tow a car whose mass is 1/4 that of the truck. This is a truck and this is a car. And towing. It is if the force exerted by the truck on the car 6,000. The force exerted by the truck on the car 6,000. Then the force exerted by the car on the truck also 6,000 Newton. Why? For any action there is an equal and opposite reaction, guys. Most of the problems that we solved now, it is related to Newton's first law. Let's complete the rest of the exam view problems in next videos. God save all of you guys.